Science in pursuit of truth tells you that, in fact, true value does not exist. In past scientific experiments, we often described the results as errors because we believed in the existence of a true value. For example, when an 80-kilogram person steps onto a weight scale, but it shows 81 kilograms, we say there's a 1 kilogram error. Speaking of weighing, we've all had experiences, even when using the same scale. For consecutive measurements, the numbers may not be the same. Moreover, if different scales are used for measurement, the variations in the readings can be much significant. In such situations, can you determine the true value of weight? If I step onto the first scale 5 times in a row, and it shows 76, 72, 85, 79, and 70 kilograms respectively, then step onto the second scale 5 times, and it shows 79, 80, 79, 81, and 79 kilograms respectively, then you would definitely know which scale's measurements are more reliable. The true value cannot be known. We can only assess whether the measurements are reliable enough. Therefore, science no longer describes experimental results as errors, but evaluates them in terms of uncertainty. The lower the uncertainty, the more trustworthy the experimental results are. When expressing measurement results, we must find the central tendency, or best estimate, from the experimental data, and calculate its spread, which represents uncertainty. Finally, the experimental results are expressed as the best estimate plus or minus uncertainty. Using the example of weight measurement mentioned earlier, we can observe that the second set of measurements has a central tendency around 80 kilograms, and its spread is noticeably smaller than the first set of data, indicating more reliable measurements. Therefore, we can have more confidence in the measurements from the second set. This is how uncertainty and error lead to different scientific understandings. Science can only tell you which results are more reliable, but no one knows what the true value is.